Good day, everyone. Let us take a look at question 3 on the gear train. The question says that in an epicyclic gear train, the internal wheels A and B and compound wheels C and D rotate independently about axis O. The wheels E and F rotate on pins fixed to the arm G. The gear E meshes with A and C, and gear F meshes with B and D. All the wheels have the same module, and the number of teeth on C is 28, the number of teeth on D is 26, the number of teeth on E is equal to the number of teeth on F, which is equal to 18. Now let us look at the diagram. This is the diagram. This is wheel A, this is wheel B. Both wheel A and B meshes internally. Then this is the compound gear DC that is fixed to this arm G about this point O. Then this gear E meshes with A, and gear F meshes with gear B. Now, the question says we should find the number of teeth on the gear A and B. Then the second question says if the arm G makes 100 RPM clockwise and A is fixed, we have to find the speed of B. And the third question says if the arm G makes 100 RPM clockwise and wheel A makes 10 RPM counterclockwise, we have to find the speed of wheel B. Now, let us look at this. From this geometry, we can say that the diameter of wheel A or gear A is equal to diameter of gear C plus twice diameter of gear E. That is, the diameter of this A starting from here to this place is equal to diameter of this gear C from here to here plus the diameter of this E. Then we have similar of this around this place. That's why we say twice the diameter of gear E. Then when we translate this one to the number of teeth, we can also say the number of teeth on A is equal to the number of teeth on C plus twice the number of teeth on E. Then from here we will substitute the number of teeth on C is given as 28 plus 2 times the number of teeth on E is given as 18, and this one gives 64. Then also the diameter of wheel B is equal to the diameter of wheel D plus twice diameter of wheel F. When you look at it, the diameter of this wheel B, which starts from here to this place, is equal to the diameter of this wheel D plus the diameter of this wheel F. Then we also have similar with this one at this end. That's why we say twice the diameter of wheel D. Then when we translate this one to the number of teeth, then we have the number of teeth on B is equal to the number of teeth on D plus twice the number of teeth on F, and this is equal to the number of teeth on D is given as 26 plus twice the number of teeth on F, which is 18, and this gives 62. Now the next thing here is, let us go and formulate our table. Now let's go straight to the formulation of our table. So as we know, the first column here is our serial number. Then the next one is the condition of motion. Then the next one is our arm G. Then after the arm, the next wheel depends on the direction of, the next wheel depends on the wheel through which the power enters the system. Power can enter through the system through this compound gear DC. It can also enter through the system through gear A. Now let us look at if it enters through DC. That means the wheel C will drive E, E will drive A, then D will drive F, and F will drive B. And if it enters through A will drive E will drive C, C and D moves together, then D will drive F, and F drives B. So in this analysis, I'm going to assume that the power enters through gear A. So you can go and try the other one on your own and see if they will give you the same result. So for that reason, I'm going to start with wheel A. Wheel A. Then after wheel A, what next? As you can see, A drives E. Then it will be wheel E. Then after wheel E, E drives C and D, because both of them are compounded together. So we talk about compound wheel DC. Then after DC, this D will drive F. Then we have wheel F. And then finally, we see that F will drive B. Now, this is what we are going to have in our table. Then the first action here, as usual, we are going to fix G and then give a positive X revolution. So that means the motion of A here will be 0. The motion of X is going to be, the motion of wheel A is going to be X. The motion of wheel E is going to be, when you look at this, A serves as the driver, E is the driven. So the motion of this is going to be, so the motion of E is going to be X multiply the ratio of the number of teeth on the driver to that of the driven, which is E. Now, when you look at the diagram, both A and E mesh together internally. They will be moving in the same direction. For that reason, it's going to be positive. This one is positive, it's also going to be positive, not negative this time around. Then after this, we now consider wheel DC. Wheel DC, we know that it is wheel E that drives DC. So how do we know the speed of wheel DC? Now, E is the driver, C is the driven. Then we say the speed of the driven, which is C, over the speed of the driver, which is E, is equal to the number of teeth on the driven, the number of teeth on the driver to the number of teeth on the driven. That is, NC is going to be NE multiply TE over TC. Then NC here is going to be NE is this one. Then this will be XTA over TE multiply TE over TC. Then from here, you see that this will cancel this. Then the speed of C is going to be XTA over TC. But when you look at the meshing, E and C meshes externally, they will be moving in the opposite direction. So that will give this one negative. For that, the speed of the wheel DC is going to be minus XTA over TC. Now, let us go to that of wheel F. Let us look at that of wheel F. You see, D is the driver, while F is the driven. So from here, to get that of F, it will be the speed of the driven divide the speed of the driver, which is the speed of D, which is equal to the number of teeth on the driver over the number of teeth on the driven. Then from here, we are looking for NF, which is equal to ND multiply TD over TF. Then from here, we know that the speed of C is also equal to the speed of D. Why? Because they are compound J. They move off together with the same speed. Then you already know NC here to be this one. So that means the speed of F is going to be minus XTA over TC multiply TD over TF. But when you look at the two J's, D and F meshes externally. So this one will be moving in opposite direction to this one. So it will be, this one will be negative. And this negative will cancel this. They will now have NF, which is equal to XTA over TC multiply TD over TF. Then we can now write it here as XTA over TC multiply TD over TF. Then finally, let us look at the speed of wheel B. Now, what happened is, it is F that drives wheel B. So the driver is the F, while the driven is the wheel B. So the speed ratio here is the speed of the wheel B divide the speed of the wheel F, which is equal to the number of teeth on F over the number of teeth on B. Then NB is going to be NF multiply TF over TB. Then we have NB is equal to, now we know our NF to be this. Then when we put this value here, we have TA over TC multiply TD over TF, then multiply TF over TB. TF will cancel TF. When we arrange this one, we have NB is equal to TA over TB multiply TD over TC. So, okay, the X is here. So we'll have the X here. Then we'll now have X TA over TB multiply TD over TC. When you look at the wheel F and wheel B, they merged internally. They will be moving in the same direction. So since this one is positive, this one will also be positive. Now, the next action here is you add Y revolution to all the elements. If you fix all of them as one body, this will be Y, 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 Y. Then the third action here is net motion. Here we have Y, here we have X plus Y, here we have Y plus XTA over TE. Here we have Y minus XTA over TC. Here we have Y plus XTA over TC multiply TD over TF. Then here we have Y plus XTA over TB multiply TD over TC. Now, from here, the summary of this is that the speed of the arm G is equal to Y. The speed of the wheel A is equal to X plus Y. The speed of the wheel E is equal to Y plus X TA over TE. Then the speed of the compound gear DC is equal to Y minus XTA over TC. Then the speed of F is equal to Y plus XTA over TC multiply TD over TF. And the speed of wheel B is equal to Y plus XTA over TB multiply TD over TC. Now, let us look at the question. So, we have answered the first one that says we should find the number of teeth on the wheel A and B. Now, let's go to the second questions. Let's go to the second question. The second question says that if the arm G makes 100 RPM clockwise and A is fixed, find the speed of B. Now, so the arm G is equal to Y, which is equal to 100 RPM. And we're told that A is fixed. The speed of A is equal to 0. And we know that the speed of A, which is this one, we have X plus Y is equal to 0. When we put the value of Y here, we have X plus 100 is equal to 0. That means X is equal to minus 100 RPM. That is, X is counterclockwise rotation. Then the speed of B, NB, which is equal to Y plus XTA over TB multiply TD over TC. When we substitute the value, the NB will be equal to 100 minus 100. TA is 64, TB is 62, multiply TD is 26, and TC is 28. Then we'll have this one as 100 minus 100 into 1.032 multiply 0.929, and therefore TB will be equal to 4.17 RPM, and the direction is clockwise. Then, okay, let us look at the third question. The question says that if the arm G makes 100 RPM clockwise and wheel A makes 10 RPM counterclockwise, we have to find the speed of the wheel B. We know that the speed of the arm G is Ng, which is equal to Y, is equal to 100 RPM. Then the speed of GA is equal to X plus Y. We are told that is equal to 10 RPM in a counterclockwise. Therefore, it will be minus. Now, we'll substitute the value of Y is equal to 100 into this. Then we'll have X plus 100 is equal to minus 10. X will be equal to minus 10 minus 100. Therefore, X will be equal to minus 110 RPM. That is in a counterclockwise manner. Then, to calculate the speed of JB, we know that the speed of JB, NB, is given by Y plus X into TA over TB multiply TD over TC. Then when we substitute the value, then NB will be equal to 100 minus 110 into TA, which is 64, over TB, which is 62, multiply TD, which is 26, over TC, which is 28. Then we have NB is equal to 100 minus 110 into 1.032 multiply 0.929. When we evaluate this, we find out that the speed of the JB is going to be minus 5.46 RPM. Since it is negative, it's going to be in a counterclockwise manner. So make sure you listen to it keenly and share it with your colleagues so that they may also benefit from it. Thank you very much.